Today we will be discussing something very fundamental in mathematics, also known as a group isomorphism. In order to adequately answer this question, let's begin with three seemingly very unrelated objects, which are a game of Sudoku, the remainders of 3, and the rotations of a triangle. If you've ever filled a Sudoku puzzle, you'll know that one of the fundamental rules of the game are that each item should come exactly once in each row and once in each column. So, having said that, let's try to fill this Sudoku puzzle. So, we know that B is in this row, right? So we cannot have B. So let's say we choose C, right? But now we have no choice but to select A, because each item needs to come exactly once in each row, right? And following a similar pattern, we know that we have to put A here because we cannot have any other item, and we need to have B here. So one fact about numbers is that all of the numbers that we know, by numbers I mean the integers, can be represented in this form: 3c plus 0, 3c plus 1, 3c plus 2. And these are all of the numbers which have either a remainder of 0 when divided by 3, or a remainder of 1 when divided by 3, or a remainder of 2 when divided by 3. So you will notice something very interesting about this particular set of numbers. So for example, if I were to take a number which has a remainder of 2 when divided by 3, and I were to add that to a number which has a remainder of 1 when divided by 3, I will get a number of the form which can be rewritten as then be rewritten as So interestingly, in this particular algebraic system, 2 plus 1 is in fact equal to 0. And I would encourage you to try to fill this table in for yourself using the exact same logic as I have used here. But for now, we will move to our next algebraic structure. Now move on to our third object, which are the rotations of a triangle. So if I take a triangle, one thing I could do to it would be to do nothing. So that would be a rotation of 0, and it would keep the triangle exactly where it is. A second thing I could do is I could rotate my triangle by 120 degrees. That will be a rotation that I will call R1. And I could rotate my triangle by 240 degrees, which will be a rotation which I will call R2. And with this in mind, we can now begin to fill our table. So, for example, rotating our triangle once and then rotating it once again is the same as rotating it twice. Rotating our triangle once and similarly rotating our triangle once and rotating it twice is the same as doing nothing, because we will be back where we came from. And by a similar token, we can fill this table. So for example, for the last one, rotating it 4 times is the same as rotating it once, because we will be one step further from where we came from. So R1. Now, do you notice something very interesting going on between this table and this table, which are seemingly very unrelated objects? So the first minute to think about it and then give you the answer. Now things have become very, very clear that these two tables are in fact the same. So we have 0, 1, 2 here, 0, 1, 2 here, 1, 2, 0, 1, 2, 0, 2, 0, 1, 2, 0, 1. Now, you will notice something very interesting between the remainders of 3 and our Sudoku puzzle. Can you see it? Let me show you. So, for example, if I were to take 0 and put it where A was, and if I were to take 1 and put it where B was, and if I were to take 2 and put it where C was. So let's perform that particular action. So A goes to 0, B goes to 1, and now if you can notice, if I were to rewrite this table again, you will notice that these two tables are also in fact identical, in the sense that just by changing the arrangement of the numbers, we have in fact come up with the same table. So mathematically speaking, two groups G and H are said to be isomorphic to each other if there exists a structure preserving map which has to be bijective, which inherently preserves the group structure. So less rigorously, what we're trying to say is that if we can come from one group to the other group by a simple rearrangement, then we have in fact shown that those two groups are in fact the same. If you found this video interesting and would like to know more about equality and isomorphisms, do leave a comment below. Thanks for watching.